Okay, so we're just gonna start by going over last night's homework. Last night's homework was just making sure you were comfortable using page 10 of the reference table. Yeah. Yeah, you weren't done when you hadn't finished it when I walked through. So anyway, last night's homework was just getting comfortable using the reference table. Those were not Regents level questions, just so you know, we'll be practicing some of those over the next couple of days. So this was just getting more familiar with the reference table. So going through, I'll give you the answers and then talk about any that you had an issue with. So number one, the lithosphere is the crust and rigid mantle. They tell you that right in the bracket where it says lithosphere. It's like got a bracket around crust and lithosphere. The two elements that compose the inner core, that's iron and nickel. You could have abbreviated it the way I did or write it out like the way it was in the reference table. The outer core is liquid. What was that? Did you just ask me how to spell something? No. Okay, good, because that was scary. So you did. The outer core is the one that's liquid, and you can tell because its temperature is hotter than the melting point. The pressure at the stiffer mantle outer core boundary, I said it was like around 1.4, but I definitely could have seen it like and agreed with you if you said it was 1.5. Do you guys agree with that or something drastically wrong? Okay. Number 5, a temperature at a depth of 3,000 is 500. What? What's 5,000? Oh, did I just literally not include a 0? Yeah, that's bad. If you definitely do that, a temperature at a depth of 3,000. Yeah, it never is down that cold. So 3,000. Yeah, that's clearly 5,000. So even though that was an honest mistake, it makes it very wrong. So you can't make a mistake like I just did. You have to include all your zeros. Number 6, at a depth of 500. Again, I changed there. There it was 500. I said 2,100. You guys good with that?
What's the little?
Oh, I'm sorry. That means approximately. So you don't have to include that, but I wanted to make sure that you knew it wasn't exactly. I screwed up number 7. I just got so used to doing temperature. I went ahead and did it originally and then realized that wasn't what the question asked. So don't screw up like me twice in a row. Make sure you read the words. It did ask for the pressure. I said it was about 3.1. I'm not sure if you can see the point. Number 8, I went with 3,100. Number 9, it's either around 1.9 or up to 2. Temperature at a depth of 5,000 kilometers, 6,200-ish. 0.2 for number 11 and 12, 6,000. Are we good so far? All right, I want to hear what you guys had to say for number 13. What layer has a temperature of 4,000 degrees Celsius? I hear 2 answers, stiffer mantle or outer core. Go ahead and grab your reference tables and check that one out. So one of those answers is correct. I'll give you that. Is it the stiffer mantle or the outer core for a temperature of 4,000? Right? Is that the number? Yep. No. Why is it the stiffer mantle? You fell for it, guys. That's why I specifically did not put that answer up there originally. A depth of 4,000 is the outer core, but I want a temperature. The reading said which layer has a temperature of 4,000. So here's a temperature of 4,000. Go over till you hit the line. That is the stiffer mantle. So if you had outer core, go ahead and change that. It's stiffer mantle, and it was on there specifically to trick you. So I don't typically like tricking you, but the Regents does. So to get you ready for the Regents to trick you, I had to trick you today. So hey, you might want to check your answer to the next question. Hint, hint. Name the layer where the temperature is 6,000. This time it is outer core. Temperature of 6,000. That happens in the outer core. Again, if you put inner core, that is a depth of 6,000. So make sure you read those directions carefully. So then you probably didn't mess up the pressure ones. Number 15 is inner core and number 16 is outer core. Did you find the mountains on this reference table? It is the Cascades, and maybe you didn't know that the Cascades are a name of a mountain range. So they do show you one set of mountains here. They also show you a trench next to those mountains. So the Cascades, by the way, does anybody know where they are? I went there this summer. It is on the Pacific. It's not right on the Pacific coast, but it's in the Pacific Northwest. Goes from British Columbia, Canada, down to Northern California. It is on the reference table. So if we look back to page 5, that would be happening right up here. So this is British Columbia, Washington, Oregon, and the top of California right here. And that part is actually a convergent plate boundary. It's less famous than the San Andreas Fault, which is a transform plate boundary that causes all the issues in California. But the Pacific Northwest up here has beautiful mountain ranges, and that is also where the Mount St. Helens volcano was. Do you guys remember what is formed almost every time there's a convergent plate boundary with ocean and land meeting each other? A trench is formed. Now, the trench is not big enough or famous enough to make it onto this map. Like, they didn't label it like they labeled all these other ones, but they did show it to you here on page 10. We've got a trench right on the coast. And the Pacific coast is very different from the Atlantic coast if you've ever been there. It is not really swimmable beaches for the most part up there in the northwest. The water drastically gets deep almost right away because it's a trench. There's also other things going on. It has a cold ocean current, which makes it cold in the Pacific, versus the eastern coast has a warm ocean current, which makes places along the East Coast warmer than the West Coast. How do you feel with page 10 of your reference table? Good-ish? Okay, great. So just to let you know, we're going to continue practicing that. I'm going to see how much time we have left to see how much homework you get. It's at least going to be page 4, but if I give you like 15 minutes, it'll be pages 4 and 5. So it'll be at least page 4. I'll hold off and let you know at the end. But in the meantime, we're going to change over to page 7. Continental drift. You guys ever heard of this before? I think so. Based on its name or what you know about it, what do you think continental drift is? The continents are drifting. Yes, TJ used different words. They're moving. They're moving. You guys know that, right? Okay, we have established the continents move around, part of plate tectonics. We couldn't have convergent or divergent or transform plate boundaries if they weren't moving. Continental drift in terms of science is a new concept. New meaning literally my grandparents, which they would have been about 100 years old. This wasn't a thing when they were kids. This was not developed and not accepted until the 50s, which I know sounds like a long time ago, but if you think of it, my mom and dad were born in the 50s. So probably your grandparents' age is how old this concept is, which in terms of science, in terms of how long people have been thinking of stuff, that's pretty darn new. So this is a new concept. It is totally accepted now. And we just need to go back to, there was some evidence back before they could actually start measuring it. There was some evidence that the plates were moving around. Do you guys know any of them off the top of your head? Great. You get to learn them all today. So we're gonna do this a little differently than just listening to me talk and write down notes. I have, they're actually just slides. They're the notes. They're basically very in-depth slides on this piece of paper here that go through each of those concepts. Let me actually pull the first slide up. We'll kind of do that one together so you can have an idea. So the first slide, which one do I want? Looks like this one. So here's the detailed directions. And what you're going to be doing is you're going to read the evidence on each slide. Then on page 7, for each slide, you're going to write a short description of the evidence presented on the slide. So on page 7, you'll notice there that there is a large box for evidence. That's going to be your notes. And then there's a small box for a picture. If you haven't gathered, I am not a teacher who makes you draw pictures just for the sake of drawing pictures. The only time I make you draw pictures is when that picture will literally help you with the concept. So if there is something in the reading that can be shown better in a picture than necessarily words, go ahead and add it. If you think a picture does not add anything to your understandings, then leave a picture off. I do recommend doing this in pencil, or at least leaving yourself some space if you do it in pen. Or if you like whiteout, just in case we need to add or take away anything once we're all done with this. So like I said, here's the first slide. So the first slide is that the shapes match. So it says the continents look like they were a giant jigsaw puzzle that could fit together to make one giant supercontinent. The bulge of Africa fits the shape of the coast of North America, while Brazil fits along the coast of Africa beneath the bulge. So do you need all of that word for word in your notes? No. So let's go through and see what we should add to the notes here. What concepts up here? Let's actually start. Sorry, I'm kind of all over the place. The first thing I want you to do is title your box. So that title, and you'll have the slide right next to you, so you won't have to remember. But the exact wording was shapes match. So that would be the title of this set of this box. And what did it say about the shapes matching? That would have been important to include. Literally the continents fit together like a puzzle. That is a good bullet. So right under shapes match, I'm going to put a bullet that says the continents fit together like a puzzle. Do you think we should include anything else in that? I think I might include just one of the examples at least. Maybe that South America and Africa fit perfectly together. Like, and it's kind of obvious too, if you see South America fitting right in with Africa, or if you want to include the, how North America fits right in over that bulge of South America, or right, and Africa, however you want to do it. I am going to include mine. I'm going to say example. South America. And that is one of the times where I think a picture might help. You could go one of two ways, I think, with a picture. You could either attempt to draw Africa and South America fitting together. I cannot, but I am going to draw just a makeshift puzzle piece. Maybe not. Well, that was pretty sketchy. That does not look like a puzzle piece. I really wanted it to, but it doesn't. So this is a case where like, if I was doing these notes, I might not do a picture. Don't laugh at me. All right, so like I said, I'm gonna give you each these readings. I'm okay again, if you guys want to work in groups. 2 or 3 people, groups of 4 can be 2 and 2, please. So I'm gonna give you these readings. You only have 4 more boxes and a picture to draw. Let's just forget about page 5 of the homework. So homework is just gonna be page 4, even though I'm not sure how much time we're gonna have. So homework is page 4. Oh, boy. Not with that marker. I'll write it up there in a second. Let me get you the papers. For these papers, I'm gonna give you each one, but if it turns out, you're welcome to write on them, but if you don't, here, take it that way. If you don't write on them, I'd like them back, so I don't have to make 80 copies. Oh my God. Here, have these that way. You do what? Look, yeah, that was supposed to be a puzzle piece. Okay. All right, so like I said again, if you want to write on these handouts, you can, but if you don't, I'd like to take them back so that I don't need to make 80 copies. So go ahead and fill in page 7, and then your homework is page 4.